Today I want to talk about the economic geography of global warming, and the work that I will be talking about in particular is joint work with Jose Luis Cruz, who is at Princeton University. So we all know about, and Joaquin mentioned, of course, the main issue that carbon emissions and the implications of carbon emissions for climate change and increases in temperature have in the world, and kind of the pressing crisis that this is generating. So in a nutshell, CO2 concentration in the atmosphere has grown rapidly since 1850 due in large part to industrialization, transportation, and other economic activity. And in this slide, what I have is the recent IPCC, one of the graphs in the recent IPCC report that shows to what extent the increase in temperature are unprecedented for thousands of years, and the extent to which temperatures have increased over the last 170 years relative to scenarios in which humans don't affect climate through CO2 emissions. And their conclusion is that temperatures relative to the pre-industrial levels have grown by about 1.2 degrees Celsius. And so, this is uncontroversial. Everyone is in agreement with the fact that those effects are there and that they're going to continue to be there, and they're going to become worse over time. And so we need to try to understand what's the impact of this on the global economy. An important complication, of course, is that this is what economists call a global externality, namely the actions of individual firms or people in terms of emitting carbon into the atmosphere mix very quickly in the atmosphere and affect everyone, affect global temperatures. And so when such a global externality is present, what textbook economics tells us is market outcomes are not efficient. We need to introduce policy. And so this is a clear phenomenon in which clearly policy is needed. But every time we think about policy, we also need to think about evaluating the phenomenon, because there's many demands for policy action. There's many demands for the resources that go together with this policy action. There's policy on pandemics, there's policy on education, there's policy on poverty alleviation. There's many, many demands. And so if we want to have effective policy action on climate, we need to think about what is exactly the cost and what are the changes that this is going to generate in the economy. And so that's kind of the agenda that I embarked on, try to understand what the impact of climate change is going to have on the workings of the economy today and in the future. And when in thinking about this, one comes to the conclusion that the cost of climate change really depend in a crucial way on the cost of changing the location of economic activity, right? So how are these two things related? It's not so obvious why they would be related. Why is the cost of changing the location of economic activity so important in determining the cost of climate change? And the reasoning in a kind of simplistic way is the following: is temperatures in the world vary between, say, 0 and 28 degrees Celsius in growing seasons. So that's kind of a fairly large range. While the most extreme predictions of temperature increases in the world are, say, between 6 and 8 degrees Celsius over the next 200 years or so. So what that implies is that, of course, some areas are going to be completely devastated by increases in temperature. It's going to be very hard to live or produce in those areas. But for some others that are very cold today, this is potentially going to be beneficial. And so there's going to be very heterogeneous effects on the different locations. The impact of the phenomenon on different locations is going to be very different. And so one, of course, way of adapting to this then is to move economic activity from the locations that are negatively affected to the locations that are going to be positively affected. And so if that transition, if that moving economic activity from one place to the other, and for us all to move to different places, or our children or grandchildren, if that's very simple, then the costs are going to be relatively small. If that's very complicated and costly, then the costs are going to be very large. And now, of course, one could argue, well, maybe there's not enough space for us, or the areas that are going to improve are not large enough to house all of us. That, of course, could be the case, but it's simply not. I mean, actually the area in which there's active economic activity is relatively small. And so this is not really an issue of the lack of space. It's more about exactly moving that cost of economic activity. And so the costs depend crucially on that. And so if we want to evaluate this phenomenon, we really need to bring in those costs and bring in the decisions of agents of where to live, etc. Now, there's many examples in history of societies moving across locations, and the rise and fall of different types of cultures across space. Brian Fagan has a beautiful book about what's called the medieval warm period, a period between the 19th and 13th centuries, where temperatures in parts of the world grew by about 1 to 2 degrees Celsius. And he documents how this was very important for the success of certain cultures, like in Northern Europe or the Mongol Empire, but was terrible and very detrimental for other cultures like the Mesoamerican cultures or the Khmer Empire. And so, there's been a lot of history of how climate has led to the rise or fall of different societies in different parts of the world. And so, again, the extent to which this can or cannot happen is going to determine the importance in economic terms of this phenomenon. And so we wanna do this evaluation. And so in order to do this evaluation, we need to bring into the analysis, of course, many locations in order to have this ability of the world economy to move across locations. And so that means, bring in innovation so that different areas can improve their productivity, etc. We need to bring fertility so that people in different locations can have different numbers of children. And we, of course, need to bring in the ability to move across locations and to trade across locations. So the goal here is to create kind of a model economy that we can then use to see or try to understand how the future economy is going to look like with or without climate change, or with more severe climate change or less severe climate change, and where we can also use to try out different policies. But we particularly want an economy in which agents, both firms and individuals, can have the option to move across locations and to decide where they want to invest and live their lives. Because that form of local adaptation, as I just argued, is essential to understand the impact that this phenomenon is going to have. And so to do that, we're going to take, the standard predictions of temperature rise and CO2 emissions from the IPCC, and we're going to fit our models so that it replicates the evolution of temperatures in one of the most extreme scenarios that they have, which is RCP 8.5. We can do it, of course, for different scenarios, but the results that I'm going to show you today are for the most extreme cases, just to highlight kind of what the potential impact of this could be in the worst case scenarios. And so, the model replicates that fairly well, as the graphs on the left show. You can see that in green, the path of temperatures that the model reproduces, and the dashed line here is the path of temperatures in that scenario. So you can see that those are virtually identical. And so in that sense, we're reproducing a realistic scenario, or like I say, an extreme scenario, but one that is very consistent with what the scientists have put forward as an extreme scenario. And importantly, then we're going to consider outcomes at a fairly detailed local level. And so on the map, in the bottom right corner, what you see is the pixels in that map, in some sense, is the level of the analysis that we're doing. And then what the map represents is the heterogeneity of local temperature effects whenever you have global temperature increases. So in particular, what the map shows is if there is a 1 degree Celsius increase in temperatures, what's the local increase in temperature? So in the very red areas in the in northern Siberia or Alaska or northern Canada, what you see is that a 1 degree Celsius increase in global temperatures or in average temperatures actually results in 2 degrees Celsius increase in temperatures in those locations. While in some of the dark blue areas in the map, the opposite is true. A 1 degree Celsius increase in temperature actually leads to less than 1 degree Celsius increase in temperatures at the local level. So perhaps a half a degree. And so that already tells you, global increases in temperature are going to translate into very different local changes in temperature, which is of course what affects local productivity and local quality of life in those places. Now, the way this kind of toy economy, in some sense, that we're building, that we're going to use as a way to try to assess the importance of this phenomenon, has different components. So let me very briefly try to explain what those components are, and then I'll jump to show you some of the outcomes that come out of this. So the core of the economic model are the two types of economic agents. There's individuals, and then there is firms. Individuals, they work, they consume, and they every period are deciding whether they want to move or not. If they decide to move, that's costly, so they have to pay a cost in order to be able to move. They provide labor and the land that they own to firms that, together with energy or fossil or clean energy, can produce different types of goods that they're going to trade with the rest of the world and with different locations. And they also have the option to innovate, and so improve the technology in a particular location. And so if they do so, then the productivity of that location increases, which in turn is going to attract more people, etc. And so that's going to create growth in certain areas of the world relative to others. And how productive these firms are, in turn, determines how high are the wages that they pay to the workers that work for them. And so, of course, if wages are high, that's going to attract more people and that like those high wages, because it allows them to consume more. So that's kind of, in a nutshell, the core of the economic model. And then this is embedded in a climate model where these firms are using energy, and this energy can be clean energy or fossil fuels. They're going to decide which one to use and how much of each one to use depending on its prices. And if they use fossil fuels, that in turn generates CO2 emissions, which affects the stock of carbon, which affects global temperatures through, as scientists tell us, that process goes. And then those global temperatures are translated in local temperatures through this map that I showed you a minute ago, through this kind of local scalar. And these local temperatures that are going to affect economic activity at the local level. They're going to affect productivity, so how effective firms are in translated inputs into output, and they are going to affect how attractive these locations are to live, which is something that I'm going to call amenities, okay? And it's a term that I'm going to use repeatedly. So these amenities represent how attractive a location is to live there, independently of the wages that are paid by firms. So just as if it's nice, if the weather is good, etc., that it's all gonna lead to higher amenities. So it's gonna be attractive for people to live in those locations. And these local temperatures are also gonna affect natality rates. So births minus death rates, okay? And so we're gonna take this model and we're gonna fit it to the data that we have on where people live and how much they produce in the different regions, okay? And we're gonna do that repeatedly and then recover these productivities in these local amenities that make this type of model exactly reproduce the data, So exactly reproduce the data for a period of 20 years. And so that's gonna give us these amenities and productivities at the local level. And then we, together with data on the temperatures in the different locations, we can try to empirically assess to what extent changes in temperature affect these local amenities and local productivities. And this is what I have in these plots on this slide. What you can see here is on the horizontal axis, you see temperatures in winter, so in January or July, depending on the hemisphere. And so you see the range of temperatures in degrees Celsius. So say from minus 40 degrees Celsius to, plus 30. So these are the different regions of the world. And what I'm plotting here is what's the effect, or what's the estimated effect of a 1 degree Celsius increase in temperature on the productivity of that location, or the amenities in the other plot in that location. And so what is this telling us? It's telling us something that I was already emphasizing before, which is in the coldest regions in the world, an increase in temperature increases productivity, while in the warmest places in the world, an increase in temperature decreases productivity, so makes firms less productive, okay? So less efficient in transforming inputs into output. And the same is true for amenities. In the coldest places, higher temperatures lead to higher amenities, while in the coldest places, we see the opposite. So you are deteriorating how attractive those places are for living there, okay, to live there. And so you see this, so this comes directly out of the estimation that we do in relating these temperatures to these amenities and local productivities. And that's of course gonna be an important input into the model. It tells us exactly that heterogeneity that we were talking about is very important, is there, and it gives us a number of how much it actually affects these amenities or these productivities. And so when we let that process go on for many years, so for the next, say, 100 or 200 years, what we see is that the accumulated effect on amenities or productivities is very large. So these maps show you that what's the effect in 2200, or what would be the effect in 2200 if we just let this process run. And what this tells you is, yes, amenities in these northern latitudes are gonna increase significantly by about 40%, while in these areas here in Central Africa and South America, they can decline by about 30% over that kind of long time period. And the same for productivities, although more pronounced. So productivities in these northern regions are about 200% larger, while in these more central regions closer to the equator, they can be lower by 50%. So these effects are very large and very significant. Notice one thing. In the what's the rich world today, so parts of the US, Europe, Japan, etc., that kind of area there is not very positively affected, but neither very negatively affected. It's kind of at the cusp of the switch in this cost. And so once you put that all together, you can say, well, how is this going to affect where people live? Say in 200 years, how is that economy going to look like? And so this map here tells you what the population density in 2200 is going to be relative to a situation where there's no warming. And again, it tells you there's going to be a lot of migration from, South America, Central Africa, and Southeast Asia to the northern part of the world. And so that migration is about 600 million people are going to change location as a result of this phenomenon. And so that's, of course, and so the phenomenon itself is gonna have welfare, is gonna affect how, the welfare of people in different parts of the world differently, depending on all these things that we've been talking about. And what you can see in this graph here in the upper right corner is kind of the bottom line. What's the effect on the welfare of an individual that lives in that location, and kind of all the dynasty of that individual moving forward, right? If we put it all together, what's the kind of net effect on people there? And what it tells you is that in these areas that I've been highlighting, the blue areas in the map that I've been highlighting as I discuss this, the effects can be as large as 15% losses for the people there. So these are massive losses for people in those regions. Again, about 15% large, and there's going to be gains for people in the northern areas that are kind of similar in magnitude, maybe a little bit smaller. But the range is very large. The range is about 30%. So very, very, very different futures for people living in these different places. And one important thing to note is that the costs are very negatively correlated with income. So places that have high income today tend to be less affected than places that have low income today. So it's the most vulnerable, poor places in the world that are going to be the most affected by this. So this is something that, of course, is a big it raises many concerns. Now, and it's in some sense very unjust because, of course, most of this problem was generated by the emissions of the countries that industrialized early. Okay, so I've been giving you some point estimates, of course, but there's a lot of uncertainty about about all of this. How important are these costs? And because we made all sorts of assumptions, and not only that, but when we estimated the effect of local temperatures on global temperatures, we also there was also error in those estimations. And so you can put all the kind of these errors together and get a sense of how uncertain we are about outcomes. So the type of outcomes that I was showing you would tell you that by 2200, so that's the dark line in this curve here, that line, it would tell you that by 2200 you would have like a decline in welfare of about 10%, right? So that's the dark curve in that line. And now the uncertainty that we have on that is significant. It can go, what it tells you is that we are 95% confident that, or the chances are with 95% probability, those losses are gonna be between 0 and 20%. So that's a big range, right? So that tells you we're very uncertain about the level of those effects. But it's still informative, of course. It still gives us a range that is limited, but it's certainly kind of a wide range. What we're less uncertain about is the relative gains and losses. So that 30% between the places that gain the most and the places that lose the most is fairly wide, and we said is about 30%. That interval, doesn't vary that much across scenarios. So we know that those some places are going to do much worse than others, and we know kind of the magnitude of those differences. Now, one thing that I've emphasized a lot before is the fact that this mobility cost, or the cost of moving economic activity, are of course crucial in establishing the gains or losses for the different regions. And so one exercise that we've done and it's kind of interesting is what happens, say, if as a result of that mass migration of 600 million people that I was telling you about, a country start to close their borders and increase migration restrictions as a result of that. What we can kind of model that and ask, well, is that going to increase the cost of global warming significantly? And what this graph is telling you is, well, we would go from this type of losses here to that type of losses. And so that's a significant increase. So what this exercise does is it says, well, what's the effect on the losses from climate change from an increase in migration cost of 25%? And it tells you, and what this exercise tells you is, well, the average loss by 2200 would increase by about a third. And so that tells you migration frictions are essential. If we want to reduce the cost of climate change or the implications of climate change, we need to allow for that adaptation. And in order to allow for that adaptation, we need to keep migration frictions small. Okay, let me take my last 5 minutes or so to think about what can we do about all of this, right? And so the standard solution that economists and others have proposed, of course, is because this is a global externality, one way to deal with global externalities is to price them. So we need to price carbon emissions. And so one way to price carbon emissions is to impose a carbon tax. And so different countries have done this in different ways. There's other ways of pricing carbon that are not carbon taxes, but you know, they essentially at the end of the day work similarly to a carbon tax. So as I said, we can take this type of model and use them to impose these taxes and see kind of what is the effect of them, how is it going to impact different parts of the world. So what this slide shows you is what's the impact of imposing different levels of a tax. And so what is the impact? Well, of course, that if you impose the tax, carbon emissions drop significantly at impact, right? And so that's going to reduce temperatures. And so that's kind of obviously the effect that we were looking for. But what this tells you, it's a little bit more complex than that. And why is it more complex than that? Because if you reduce carbon use today, one of the effects that has is that, you know, in the future, the cumulative carbon that you've used is going to be lower, which is going to lower the cost of extracting that carbon from the earth. And so because of that, the more carbon the less carbon you use, the smaller the cost of extracting carbon. And so that kind of tends to cancel the effect of the tax. And so one kind of bottom line of that is that what carbon taxes do is they reduce CO2 emissions in the first periods or over, you know, relatively long periods, but for a while. And then afterwards, they actually increase them because this effect that I was talking about tends to cancel the effect of the tax. And so what that does is it lowers temperatures, but essentially what it does is it flattens the temperature curve. And so you can see that in this graph here, how the different taxes, yes, they lower the curve, they flatten the curve, but at the end of the day, you kind of end up in the same place pretty much in the very long run. And so that, of course, so what are the costs and benefits of that? Well, it has a cost for the economy today because it's more costly to produce, but it has a benefit in the future because temperatures are lower, and so we don't face the effect of climate change. But because essentially we're trading off consumption today of carbon today versus consumption of carbon tomorrow, the effects are not as large. They are much larger if an abatement technology, a technology that deals with the consequences of carbon in the atmosphere, is forthcoming. If that's the case, right, if a technology is actually forthcoming, then we have this big advantage, which is that delaying the use of carbon becomes very useful, okay? Why? Because then, you know, flattening the curve and delaying carbon use essentially brings us to a point whenever that abatement technology is ready to have used less carbon and where temperatures are smaller. And so it's very important to combine pricing carbon with abatement technologies or something that comes with this. We also analyze clean energy subsidies very quickly. Clean energy subsidies don't do the trick. Why don't they do the trick? Because yes, they increase the use of clean energy in relative terms, more clean energy, less fossil fuels, but they also make energy cheaper overall, increase the total use of energy. And so at the end of the day, in our calculations, they affect CO2 emissions very little. Okay, so I'm out of time, so let me just give you the basic takeaways. Very important to do policy, to do the evaluation of this phenomenon in order for us to be able to design and determine what are the policy priorities. Second, these effects are extremely heterogeneous across space. Adaptation and the spatial frictions resulting from that adaptation are essential to value how important it is going to be for the different regions, and the actual impact that we obtain for the different regions is very correlated with income. So the poorest regions are the most affected, right? Carbon tax is a solution, but it essentially flattens the temperature curve. So only if a solution, if a cure in some sense is forthcoming, are these carbon taxes really, really effective. And so investing in abatement technology and carbon substitution is a must. Let me stop there and get some of your questions and comments.
Esteban, thank you very much for this inspiring presentation. Before we start with our discussion, I would like to encourage our audience to ask questions on menti.com. So please go to menti.com and log in with the code 7059-7074. And let me start to give you some of the questions that have come in while you were speaking. So one member of the audience asks, if the impact of climate change is heterogeneous across regions, then isn't trade one of the ways in which we could just reduce and mitigate this impact overall, and that might reduce the heterogeneity at the end of the day?
Yes, that's a wonderful question. Trade can be very effective as an adaptation mechanism because it essentially allows regions to change specialization, to change what they produce, and in a way that is more consistent with the new climate or the new climate reality, and then simply trade that good for whatever else they want to consume. And so that kind of basic changes in specialization through trade are important, a potentially important adaptation mechanism. There's another issue that makes it a little bit harder, which is that most trade is very local. And this climate phenomenon is very spatially correlated, meaning locations that are close to each other tend to have similar shocks. So to the extent that trade is local and shocks are also similar across locations that are close to each other, then it works less as an adaptation mechanism. So that goes against trade as an adaptation mechanism. So it is an adaptation mechanism, but its effectiveness depends on the overall level of trade costs. If trade is very local, it's not going to be that effective. If trade is less local, it's more effective. So if you are a manufacturing producer and this is about changing your specialization between the particular type of manufacturing that you do, and those are easy to trade, then trade can be very effective. If, on the other hand, we have societies or economies that are very, for example, specialized in agriculture, and they have to switch into other sectors where they are not as good, that transition is harder. And in particular, if they mostly trade locally with the rest of their communities, the rest of their communities are going to face exactly the same type of problem. And so trade at that local level becomes less of an effective adaptation mechanism. But this framework is one in which we can also do that type of evaluation of the impact of trade costs as an adaptation mechanism. Another important part of trade is that it can substitute as an adaptation mechanism from migration. So migration, I pointed out to migration as an adaptation mechanism, but if you use more trade, then you need to migrate less. So they are substitute adaptation mechanisms. And so trade can be an effective mechanism where migration is not an option.
Great, thank you for that. There's quite a few questions about this, so let me try to aggregate them into one. There's quite a few questions about the political economy implications of this. So you pointed out that the people who will benefit the most from climate change mitigation, reducing CO2 emissions and so forth, mostly live in poor countries, and the cost will have to be borne overwhelmingly by people in rich countries. So people are asking, what kind of mechanisms can you think of? What's the right way to engineer some kind of give and take that this ultimately welfare-enhancing deal can be struck for the benefit of mankind?
Well, that's the million-dollar question, I guess. How to design a system that is both, is compatible with the participation of everyone, but also with the basic is just in a way that reflects the history of this phenomenon and the fact that some countries are more responsible than others for generating it. I think it's been very complicated to generate such a deal. Now, whatever it is, it has to involve the rich world transferring some resources to the poor world, both because of this basic issue of fairness that we were talking about. They were not responsible for this, but also because ultimately everyone is going to face the implications of the actions that individuals in these regions are going to take in order to adapt to climate change. So you can, and so, the rich world is going to have to either admit millions of people that are climate refugees, or, find solutions to this problem that involve the switch to different technologies or carbon pricing in the rich world, and at the same time also incorporate the poorer regions into those schemes. And so, Nordhaus has many ideas on how to solve that political type of economy problem, like create clubs that give privileges to particular groups of countries that commit to certain carbon policies, and then let new countries come in as they are willing to come in. And so, but I think the ultimate issue is, and the ultimate question for the rich world is it useful to unilaterally do something? Or how much, or another way of asking that question is, even if we don't find a global solution to this problem, should we expect Europe, the US, Japan, the rich world to jump in, impose some policies within these countries as price carbon, invest in innovation, etc., and then help or use some of the resources that are going to come out of that pricing in order to help pay for some of the transition in the poor countries? And so we again can do that calculation in this. There's substantial leakage. So namely, if these countries impose the policies on their own, their economic activity is going to shift to other parts of the world. And so the question is to what extent the rich world can live with that, and to what extent the poor world evaluates those gains, that leakage that is going to go to their own countries relative to the benefits from not facing the type of consequences that I was putting together. In order to do that trade-off, to understand that trade-off, we need many calculations at the local level. I gave you one, which is the cost side for those local economies. They also need to calculate the leakage, how much economic activity is going to come from there. And so what would be the value of not participating in these global deals? And only when they know this, and when they can understand that trade-off, and when the rich world understands also what the cost is going to be of the reactions of the people and firms in those countries in terms of moving to the rich world, etc., can we kind of actually understand the type of policy that could be successful. So far, we haven't found that, because I think we've been not that successful in quantifying these local effects. And so that's kind of the agenda. We're still not there in terms of fully designing an incentive compatible agreement, but the hope is that this work is going to help us get there.
Okay, so if I got that right, then one of the things you're saying is maybe we don't just need these international agreements to solve these political economy issues, but if voters in the rich world dislike migration sufficiently much, that alone can be reason enough to do climate mitigation, because otherwise, as your model suggests, 600 million people will move. Now, on the point of migration, that was just something that came up in the questions and that I would like you to clarify. So I think the welfare calculations, the amenity calculations, and the migration thing on top, I think people followed. But the implication would be that overwhelmingly people from poor countries move to what today are quite rich countries. So that for the migrants should generate a very large welfare gain, dollars on the sidewalk. And is that a part of the calculations that you've shown us, or is that on top?
So what I showed you, I mean, there's migration in the world and there's incentives to migrate in the world independently of the phenomenon of climate change, right? And so that's in the underlying dynamics in the model. And then we can think about how does climate change itself affect those dynamics, with or without climate, or with different levels of climate change. And so what I showed you is the difference between those two outcomes, right? So there's, of course, a bunch of gains that come from migration that will happen anywhere in the world, and shifts in economic activity that will happen anyway in the world that are in some sense differenced out by doing the calculation the way I'm doing it. Migration is a very useful mechanism in the world overall, and also in this model. And so, there's an argument here to lower migration frictions if you want to increase welfare in the world anyway, independently of this climate question. Now, of course, that is, again, the impact of that, of course, is heterogeneous across space, again, because some places may get very congested, and so the quality of life there may go down, but some others are gonna become more productive because that agglomeration is conducive to more investments and growth. And so that's going to vary depending on the location. But there's an underlying benefit from migration that is not accounted for in this calculation. In this calculation, the part that is accounted for is only the extra migration that comes from the climate phenomenon.
Mm-hmm. Okay, thank you for that. So one question says, your project seems to focus on the direct impact of warming. What about flooding, climate variability, and the risk of a tipping point in our climate system, with maybe the Gulf Stream changing direction, and then discontinuities in how the world climate suddenly looks?
Yes, so that's a great question. So that's definitely correct. So everything that I showed you is the effect of warming itself. And I show you, where I emphasize 3 particular channels in which that impacts the economy. It affects productivities, it affects the quality of life, or what I've been calling amenities, and it affects this local natality rate, so birth minus death rates, right? So it has these 3 effects. And we're estimating the effect that climate has on these productivities, these amenities, and also these natalities, even though I didn't go over that in detail, from the data. Now, that data already includes whatever phenomena come from the higher temperatures and affect productivity and amenities. And so if that comes from extreme weather or more rain or other, phenomena that are linked or correlated with the higher temperatures, they're going to be accounted for in this calculation. Now, one aspect that is not accounted for at all is the rise in sea levels, that is going to inundate particular areas of the world, and therefore is going to make them not suitable for production and for living. Now, so we've done that calculation in other work, and so we've have work that has, in some sense, focused specifically on sea level rise with a similar framework where we take this type of adaptation again very seriously. And what that shows is that this type of adaptation by mobility is even more important for flooding. And so that really reduces the cost of flooding in an important way, because if you think about it, over 100 years or 200 years, the ability to move out of locations that are subject to flooding is very high. It's relatively easy to move away from those locations. Now, of course, there's all sorts of buildings and investments that have been done in areas that are subject to flooding. So that would be lost, and so there's a cost associated with that. But over 200 years, all these buildings and all these investments are going to depreciate in an important way. Namely, society is going to have to build them again because they naturally get destroyed over time anyway. And so as long as society has the right incentives to move it and to build it in different areas, the cost of flooding is going to be more or less contained. So our estimate is about 0.5% in terms of welfare. So overall for the world, again, there's variation and depending on the particular assumptions that you're making, etc. But it's a much smaller phenomenon in scale than global warming, than the effect that I was showing.
Okay, so there's one question here that I think the non-economists might be particularly concerned with. Is it cynical to talk about benefits of global warming? And is it even dangerous to suggest that there might be a silver lining to climate change because it might reduce the political impetus to do as much as possible to reduce CO2 emissions?
Yeah, I mean, again, interesting question. There's no agenda. There's no political agenda or policy agenda in the work that we do. The work that we do is agnostic to all of that. It's just trying to say, well, let's try to model the economy in as accurate a way as we can. Let's bring this phenomenon in the most accurate way that we can, in a way that we can deal with all these different forces, etc. And let's look and try to understand the outcomes. And so in that sense, I don't want to introduce any sort of political agenda to these studies. I want these studies to speak for themselves and tell us what the outcomes are. And then we can have a policy discussion on top of these results. So if the results tell us some areas are going to benefit, some northern areas are going to benefit as a result of this, I'm going to tell you that. And it should be part of the debate. And now, if that's going to facilitate or make the discussion, the policy discussion harder, is something that should not affect the results that I'm getting and my ability to present those results to you. They should, on the contrary, I mean, they should become part of that discussion, because only if we know these effects, only if we understand these effects, only if we have accurate estimates of the effects, can we really target policy correctly. I think the fact that economic activity is going to shift location and that investing in some of these northern areas is important in order to diminish the implications of this phenomena, it's an important thing to consider. And we need to think about it and we need to plan for it. And just ignoring it is not going to lead to the right policy.
Okay, a bit more of a technical question. So in the way you sort of calibrated the amenity changes and the productivity changes, are you then when you extrapolate to, say, the year 2200, making hugely out of sample predictions, and how, if that's the case, should we think about these gigantic welfare gains in areas like Siberia and Alaska, where, you know, we're probably going to be in a world in which we produce much less in terms of agriculture, where the value of land itself as part of the aggregate production function is ever smaller. So why should there be these gigantic welfare gains in what are now the most deeply frozen parts of the planet?
Right. Well, I mean, so it's definitely out of sample, big time. Now, the question is, what's the alternative, right? So the reason, so this is exactly the reason why, because it's so out of sample, why bringing in like a structural model that starts from the individual behavior of agents and built from there, so in economic lingo, has micro foundations, is so important, because, you know, we're bringing in what we know about the workings of these economies and the interactions between locations, etc., to try to tell us how the economy is going to evolve, rather than simply extrapolate from the effects that we have right now. And so this is exactly, in some sense, the reason why we think that, you know, using structural models is important, particularly for this topic, that we cannot simply extrapolate empirically from the effects that we've seen so far. So that's one issue. And then in terms of the evolution in these northern areas, etc., it's not only agriculture or the use of land. It's just the fact that, you know, people, those areas are going to be nicer to live in and better for production. And so more firms and agents are going to decide to go there. As more firms and agents decide to go there, they're going to invest in those locations. And so that's naturally going to lead to feedback effects that are going to develop those places. And so this is an outcome that comes naturally, not because land is going to be used extensively for massive agriculture, although parts of Siberia certainly have a lot of land that could be used for that. But it's not so much that aspect. It's more that, you know, those areas are more attractive, and so that's naturally going to lead to growth and development of those areas through this kind of endogenous investment channel. You know, at the end of the day, that channel seems, you know, very prevalent in the world, in the sense that, you know, if you look at the economic activity and the location of people, you know, it is definitely concentrated in locations that have temperatures that are in a particular range. So you know, that basic cross-sectional fact, although there's, you know, all sorts of identification problems in thinking about it, is very striking. And so what we're trying to model is that phenomenon, how just better temperatures in certain areas are going to then lead to this growth phenomenon over time that is going to develop them and develop cities there, and that in turn is going to make them more attractive progressively. Now, remember, this is happening over over centuries, right? So it's happening over many years. It's not that something that is going to happen tomorrow. And so, you know, lots can happen in a century. Look at how the economy, our economy today, how it was different, you know, 100 years ago. The transformation has been massive. And so that's what we're talking about. What are we expecting, and where are we expecting that economic activity to be in 100 or in 200 years? And so there's a lot of room for that adaptation to happen in 200 years.
Okay, final question. How big is the 10% average estimate that you show us as a sort of adverse impact in the year 2020? Could be 15, could be 20. So your colleague John Cochrane in a blog post recently made the point that, you know, currently the difference in incomes between richest and poorest countries is on the scale of 50 to 1. Areas like Europe are probably 30% poorer than they could be if they had different sets of regulations and incentives in place. So compared to all these economic issues, isn't 10% for climate change 200 years down the line trivially small?
Yeah, so that's a good question. First of all, a lot of these effects that we're talking about, I mean, they are present discounted value calculations. So, we can look at one particular point in time, but I mean, they imply very large overall declines of economic activity in particular regions. So 15% decline in present discounted value, of course, is way bigger than any sort of crisis that we recently faced or the Great Recession or any of that, right? So these are much larger effects than that. But when we compare to the Industrial Revolution and the effect that the Industrial Revolution has, or like you said, of eliminating many regulations, these costs are not as large as Industrial Revolution, perhaps similar to some of these other regulatory costs. I mean, I think that's fine. I mean, that's the cost and benefits, and so that again, should tell us, to what extent we want to compare to other policies. Now, one important aspect is how costly, is it to fix the problem relative to, in these different areas. We can calculate, well, a world without frictions or regulatory frictions would be a world in which we would have 30% more production, but can we really get there? Is that a feasible world in any sort of way? Well, now, so taking into account kind of the cost of the policy remediation in some sense is important too. But again, it is. I'm not saying that they are particularly large. I'm not saying that they are particularly small. I'm just telling you what we are estimating them to be. And again, that should be contrasted with estimates on other policies to establish policy priorities. My sense is that, if we're willing to be very active and proactive in terms of the effects of particular crises, say the Great Recession, or as we were for the Great Recessions, or as we are for the current pandemic, these costs are as large or larger than that. And so, that should lead to the same type of urgency that we've seen in these other policy realms. Now, is it, again, is it catastrophic? Is it going to end humanity and the economy? Well, that's not what we're getting either. That's true. It's not what we're getting either. So it also should measure, in some sense, the reactions and give us a little bit more of realistic numbers. What are we actually talking about? And again, these numbers vary tremendously and are very influenced by the fact that people are going to react, and firms are going to react as a result of this phenomenon. They're not going to stay still. People are going to move, and so the economy that results may be very changed, right? May be very different than the one that we have today. And so that's the 600 million migrant example or case or outcome that I was giving you, right? That economy looks very different because of that. And so we need to make sure that we are, in some sense, fine with that economy, that we understand that, yes, this cost is what it is, but that economy of the future is going to be a very different economy.
Thank you so much, Esteban, for these thoughts. You've given us plenty of food for thought. I would also like to thank the audience for watching and for all your questions. And this fall, on November 9th, we will have a half-day conference on the topic of climate change in Zurich as part of our Forum for Economic Dialogue series. In addition, there will be a live stream for the audience who cannot attend in person. We are proud to have Nobel laureate Jean Tirole, who will speak about the political economy of climate change, very much along the lines of questions that we just touched on, and Walter Kielholz, former chairman of the board of directors of Swiss Re, who will provide us with a perspective of one of the world's largest reinsurance companies. We will also discuss sustainable investing and climate change with leading industry experts. Therefore, if you're interested in these topics, please consider subscribing to our newsletter to receive updates on our events and activities. We look forward to welcoming you back in November. In the meantime, I invite you to follow the discussion on social media, Twitter, LinkedIn, and YouTube. You can also find all information on the forum at the UBS Center webpage, ubscenter.uzh.ch. And with that, thank you and goodbye.